Hello, ladies and gentlemen, and welcome to the next section. Section 2.4, the chain rule. Now, why do they call it the chain rule? Because when you take these derivatives, it's almost like a chain reaction. Let's check this out. Now, part of this is going to be a little bit of review from this summer packet. Recall that dy dx represents the rate of change at which y changes with respect to the rate of x changes. Basically, it's the derivative of y with respect to x, or as you know it, the slope. Specifically, the slope of the tangent line. So let's go ahead and look at something real quick. The chain rule involves the derivative of a composite function, f at g at x, where g is on the inside and f is on the outside. Now, we talked about functions that have an inside and an outside a little bit on the review packet. We're going to practice this a little bit more before we take some derivatives so that we can get a better understanding of how to do the chain rule. Let f at g at x be 2x plus 1 all raised to the fourth power. What I want y'all to do right now, pause the video, and I want you to tell me what you think f of x is and g of x. Keep in mind, f of x is on the outside and g of x is on the inside. Having paused the video, I hope that you saw that g of x, the inside function, is 2x plus 1. It's inside the parentheses, kind of a giveaway. F of x is going to be x to the fourth. That's the outside function. Now, hopefully that's a little bit evident. Go ahead and practice another one real quick. Let f at g at x be the sine of x squared. Pause the video, write down what you think the outside function is and the inside function is. What is f of x? What is g of x? After pausing the video, I hope that you saw that the inside function, g of x, is x squared. And the outside function is f of x, the sine of x. Okay? This is, again, just trying to see if you can see the inside and the outside. And I also want to recall, I want you to notice that when we start taking the derivative of this, notice that the majority of the time, it is the power rule that we're using, okay, in conjunction with all the other rules that we're using. All right, there we go. If the derivative of f at g of x is taken, then we get f prime at g at x times g prime at x. Simply put, ladies and gentlemen, we're going to be taking the derivative of the outside and taking the derivative of the inside. We're going to practice this with this function that you see here. The derivative, we're going to take the derivative of 2x minus 7 all raised to the third power. In order to do this, ladies and gentlemen, though, we do need to break it up into an outside and an inside. So, let's find the inside function. Did you write 2x minus 7? Because if you did, excellent job. Now, write the outside function. The outside function, ladies and gentlemen, should be, you got it, x to the third. Now, ladies and gentlemen, trying to organize the way we do this, I'd like you to find the derivative of both of these. Find the derivative of g of x and find the derivative of f of x. Pause the video, do it real quick. After pausing the video, I hope you see that the derivative of the inside is 2, because the derivative of 2x is 2 and the derivative of negative 7 is 0. The derivative of f of x is 3x squared. These are all the pieces that we need. We just need to put them together in a way that will help us write the derivative of this composite function using the chain rule. And the way we write it, ladies and gentlemen, is this way. We're going to say that the derivative of a composite function f at g at x is f prime at g at x times the g prime of x. And this means 3 times x minus 7 squared, we're using the derivative of the outside, plugging in the inside function, times the derivative of the outside function. So once again, the 3 and the squared come from the derivative of the outside function, f of x. The inside function is in there, but then we multiply by the derivative of the outside. I mean the inside, sorry. Oftentimes, these pieces do get confused and mixed up, so we're just going to do some practice so we can get a better understanding of how to do this accurately. Okay? So ladies and gentlemen, let's look at the next example. Oh, and I forgot. Yeah, simplification is necessary. 3 times 2 happens to be 6. So there you have it. Alright. Now we'll go to a different example. And feel free to rewind the video if you need to. Ladies and gentlemen, this function that we're taking the derivative of is 3 times 4 minus 9x all raised to the 4th power. Okay? Let's first find the inside function. Pause the video, write down the inside function. You should have written 4 minus 9x. That's inside the parentheses. That's inside function. Now the outside function. Pause the video, see if you can get this one correct. Did you write down 3 times x to the 4th? If you did, great job. You're able to look at a function and go, oh, here's the outside, here's the inside, and that's really key to this, to chain rule. Okay? Now go ahead, pause the video, take the derivative of each of these, and we'll combine them. After pausing the video, I hope you see that the derivative of the inside function is negative 9. The derivative of 4 is 0, and the derivative of negative 9x is negative 9. Now take the derivative of the outside function. You'll see that f prime is going to be 12x to the 3rd power. Okay? Now, ladies and gentlemen, we're going to successfully put these together using the chain rule again. F prime of g of x times g prime of x. Alright? So let's see what this looks like. First, the derivative of the outside with the inside plugged in is going to be 12 times 4 minus 9x to the 3rd power, and the derivative of the inside is negative 9. Now, I forgot the last time, but this time I won't forget. Let's go ahead and simplify the things that we can simplify. Turns out we can multiply 12 times negative 9, and that will give us negative 108 times 4 minus 9x to the 3rd power. Okay? Alright. I believe there's one more example, if I'm not mistaken. Yes. And actually there's a couple more. There's 2 more examples. This one involves trig. So, let's first find the inside and the outside. Pause the video. Write down the inside function, g of x. Write down the outside function, f of x. G of x is x squared minus 4x. The outside function, you got it, it's sine of x. Now take the derivative of each of these. Again, pause the video, see what you can get. I hope you wrote 2x minus 4. And the derivative of the outside function is cosine of x. Now pause the video. I want to see if you can combine these together. See if you can put the derivative, let me put it to give you the little framework, see if you can put the inside function inside the derivative of the outside function times the derivative of the inside function. Sorry. All right. After pausing the video, I hope that you wrote cosine of x squared minus 4x times 2x minus 4. Now, there's really nothing to simplify here. I mean, to be honest with you, nothing can be multiplied or added or subtracted. Just a nice little nomenclature, the way we like to write stuff in math. We put the 2x minus 4 in the front of the cosine. But, are there points taken off of that? Nah, not really. Okay. Well, there's a reason why I showed you chapter 5 derivatives, because the next example is going to use chapter 5 derivatives. Let's look at that real quick. Oh, wait a minute. I forgot. I wanted to give you the chain rule in other words. So the derivative of a composite function is f prime at g at x times g prime of x. It's basically the derivative of the outside times the derivative of the inside. You want to think of it like that. Okay, the derivative of the outside times the derivative of the inside. And I've been saying that throughout, but I forgot this slide was in there. All right. Turns out there's 2 more examples. Go ahead, pause the video. Let's take the derivative of 5 tangent of 4x. You should have got 5 secant squared of 4x times 4. The 5 secant squared is from the derivative of the outside, and the 4 is from the derivative of the inside. Simplification does require us to write 20 secant squared x to the 4th. All right. Now this is from chapter 5. In order to cover more material in the same amount of time, we will take the derivative of y equals e to the f of x. In other words, we had the derivative of e to the x, and the derivative of e to the x is just e to the x. It's its own derivative. However, if you raise e to the x to a function, all right, you have to take the derivative of the inside, which is f prime of x, and then you multiply it times e to the f of x. So essentially, it still holds, and we'll discuss this a little bit more, why e to the x is its own derivative, but this is the chain rule for e to the x if you raise e to the x to a function. Here's an example using it. Ladies and gentlemen, see if you can do this on your own. This is y equals e to the 2x minus 5. To take this derivative, you should notice that, the derivative of the exponent is 2, and then you just rewrite the function e to the 2x minus 5. Again, 75% of the time we're using the power rule, so we just couple it with all the other rules that we've dealt with, like product rule, quotient rule, chain rule, square root rule, trig rules. More examples. I'm so sorry. I forgot how many examples I put on this. Let's do e to the cosecant of x. I know I'm throwing in transcendental functions with our trig function, so let's go ahead and do this. Pause the video. Hopefully you can get this. Ladies and gentlemen, it starts with a c, so you know the derivative of this is going to be negative cosecant x cotangent x times e to the cosecant x. think I threw in a doozy here. Yeah. So, ladies and gentlemen, check this out. Not only do we have to use the chain rule, but in this one, we're going to use the chain rule coupled with the product rule. Because we're multiplying e to the x squared times cosine of x. But don't worry about it. It's not a big deal. Check it out. First, ladies and gentlemen, we're going to look at f of x. That's e to the x squared. Then we're going to look at the derivative of that. Well, the derivative of e to the x squared is 2x times e to the x squared. Well, what's the second function? It's cosine. Starts with a c. This will give us negative sine of x. Now, this is not the chain rule, except for the fact that f of x is using the chain rule. This is actually the product rule. So remember, the product rule says that you're going to take the first function times the derivative of the second plus the second function times the derivative of the first. And in all fairness, ladies and gentlemen, there's not much to simplify here except that negative on the sign. Convention says to put it in the front, so that's the only difference. And I believe that's the last example. We'll do more examples in class, ladies and gentlemen. Thank you so much for watching this video. Remember, if you haven't done so already, subscribe to my channel. The grind is real. Alright. Oh, wait. There's some more. Voila. Oh, yeah. I don't think I would have done this last part, but they factored out, since there was a negative e to the x squared common in both terms, I factored it out. But that's just me being a total nerd. Sorry about that. Yeah, there's the assignment, but I'm not giving you those problems. If you want to see them, you can, but I'm going to assign you different problems from there. Thank you for watching.